Boys and girls, this is Mr. Manise here again with another super cool, amazing video. And in this video, we're going to be talking about functions and function machines and how I can determine whether or not something is a function and how it applies to the real world. So you guys have seen this word function. You've probably seen the function machine. You've heard these terms before. The word that I want to populate into your brain when you see and hear the word function is I want you to think of the word depends. That's why we have independent and dependent variables. A function is nothing more than a simple way of saying that, you know what? One quantity, one variable depends on another. Okay, one thing is dependent on another. I can't tell you the output until you give me the input. So that's why we use this function machine. Okay, so I'm going to stick in an input. I'm going to stick in some value of x. It's going to run, crunch the numbers, crank out the numbers, and it's going to spit out one output. Okay, so if we have an equation here, f of x equals 2x plus 1, what is this whole f of x stuff? What does this mean? First thing you got to understand, f of x and y are interchangeable. Okay, f of x is just a simple way of saying, you know what, this is my output, this is my y. I can't tell you what y is until you tell me what x is. Mr. Manise, what's y? I don't know. I have no idea. It depends on what x is. If you give me x, I can plug it in, and then I can tell you what y is. You give me an input, you plug in an input, I can spit out what the output is. The f of x, that just means function of x. F is the function of y. I can't tell you what y is until you tell me what x is. If I wanted to evaluate my function, say for 3, and we'll do this here a little bit more in a minute, that simply means I'm going to stick in 3 into this function machine. I'm going to plug it in right here, stick it in. It's going to run, crunch the numbers, and it's going to spit out 1 and only one value. So if I plug in a 3, that's going to be 2 times 3 plus 1, which of course is 6 plus 1, which is 7. So if I stick in a 3 right here into my machine, it better crank out 1 and only one answer, and it can only crank out 7. I can't have two different answers. I can't stick in 3 into my machine and have my equation spit out 7 and 10. Okay, that would not be a function. Okay, one quantity depends on another. Y depends on X, and I can only have one output for each input. Let me give you a silly little example. Let's say instead of having a function machine, let's say that we have a crock pot. Okay, we're talking about food. All right, in the first time I'm going to stick in, let's go with chicken breast. Okay, and my crock pot is going to spit out barbecue chicken. Okay, that's fine. We can do that. My wife used to do that all the time. And let's say I can have two different inputs give me the same output. Okay, I can have that. So I can take my chicken fingers, I can do this, and I can stick that into my crock pot. I can stick that into my function machine, into my food machine, and it can also spit out barbecue chicken. That's fine. I'm taking two different things and I'm getting out the same thing. That's fine. No problem. Okay. I can have two different inputs giving me the same output. That's possible. What I cannot have is I can't take this same crock pot, I can't plug in chicken fingers and have my crock pot spit out barbecue chicken and also spit out cereal. What? Okay, can't do that. My wife used to do this all the time. We would have chicken, one night, and she'd keep the leftovers the next night, throw it into a crock pot with some other chicken, and we'd just be like a big stew, barbecue chicken. It was awesome. She used to do that all the time 78 years ago, okay? Well, I can't take chicken fingers, stick it into my crock pot, and get out two different things. That's not happening, okay? That's no good, okay? That's not a function. I cannot have two different outputs for the same input. Okay, so hopefully you guys are okay with that. So let's move on to a kind of a real world analogy. You guys know I'm real big on the real world stuff. How does this pertain to the real world? Well, we're talking about function machines and f of x, but in the real world we don't have x's and y's and function machines. We have items and dollars and time and months and iPads and the cost of goods and all this other stuff. So let's say that I like Burger King. McDonald's is good too. I think actually I think Burger King has the best hamburgers, but I think McDonald's has the best everything else. So let's say that we go to Burger King. I'm going to Burger King. I like their hamburgers, and we're buying hamburgers. Okay, and let's say that one hamburger costs $5. So every time I buy a hamburger, I'm ramping up $5. Okay, so if I plot this, I buy one hamburger, that costs $5. I buy two hamburgers, that costs $10. I buy three hamburgers, that should cost $15. Okay, that is a function. Every time I buy a hamburger, I have one and only one Y. I have one output. I buy one hamburger, I pay $5. I buy two hamburgers, I pay $10. I buy three hamburgers, I pay $15. But what happens if my graph looks like this? Let's go on up the scale. Okay, what if my graph looks like this? I got a straight line, okay, and then I go vertical, and then I kind of go sideways. Is that a function? Okay, well, let's think about this. For every input, I can only have one and only one output. Okay, and this is why this is not a function. This is the way I think about functions in terms of the real world. Basically, what we're saying is, I go to Burger King on Monday, and I buy myself 3 hamburgers. Okay, I buy 3 hamburgers. That corresponds to a cost of $15. I go back to that same Burger King on Tuesday. I buy those same 3 hamburgers again, but now instead of it costing $15, now it costs $20. Huh? That didn't make any sense. How can buying 3 hamburgers cost $15? I turn around and buy those same 3 hamburgers and now it costs $20. I can no longer say that the cost depends on the number of hamburgers. If I tell you guys I'm going to Burger King, you say, Mr. Manise, how much money are you going to spend? I don't know. It depends. It depends on how many hamburgers I buy. Okay, but if I get 2 different outputs for the same input, then it no longer depends on the number of hamburgers. It depends on something else. It depends on maybe the manager doesn't like me and he's in a bad mood. He's charging me more money for the same amount of hamburgers. It no longer depends on the price or the cost or the number of hamburgers. It depends on other factors. It depends on other things. Okay, so this is why, and we're going to talk about this in a second, this is why the vertical line test is so useful. I can't draw a vertical line down through the same X input and have 2 different Y values. Okay, that doesn't make sense. This doesn't make sense in the real world. Okay, so let's keep going and let's talk a little bit about evaluating functions. Evaluating functions. So when you guys see this kind of notation, let's say we have something like f of x is equal to negative 5x minus 3, and I'm evaluating that function for, say, 4. Okay, all that means is this is my function machine. I'm going to stick in a 4 and I'm going to see what comes out the output. So I just plug in a 4 where I see an x. That'll be negative 5 times 4, which is negative 20, minus 3, and that will be equal to negative 23. Okay, so that's my output. Let's say I had, and it doesn't have to be f of x. Let's come up with another silly little analogy, hamburger analogy. Instead of f of x, let's use h of x for hamburgers. Let's say that we have the hamburgers is, x plus 4, and I want to evaluate for, I'm really hungry. I want to evaluate for 5. I want to figure out what is my cost if I buy 5 hamburgers. I'm simply going to plug it into my equation, plug it into my function machine, and of course that's just going to be 5 plus 4, which in this case could be 9, and it could be dollars. It could be, number of patients in a hospital. It could be all kinds of stuff. Okay, let's ramp up the difficulty a little bit. Let's say we have g of x is equal to negative 5 halves x, let's say, I don't know, plus 7, and I want to evaluate my function for, let's go with negative 4. Okay, so I'm going to plug in a negative 4 here, so I have negative 5 halves times negative 4 plus 7. Okay, multiply across the top. Negative 5 times negative 4 is positive 20. Positive 20 divided by 2 is 10. Plus 7, and that will be equal to 17. And notice every time I'm getting exactly one output when I stick in the input. I'm only getting one answer. Okay, that's the whole point and the gist of functions and evaluating functions. Okay, so let's move on and let's talk about the vertical line test. Vertical line test is a very useful tool when you're given a graph and you're trying to determine whether or not a graph is a function or not. So let's say I just have my normal basic line, and the vertical line test is, you know what, if I draw a vertical line anywhere on this graph, I should only cross that line at one spot. And what that means is this spot right here corresponds to an x value and a y value. Okay, this spot on the graph corresponds to one x value and one y value. For every x down here, I have one and only one y output. I'm not going to 2 different y's. Okay, if I have a graph that looks like this, say it looks like this. If I draw the vertical, so this is a function. That's good. Okay. This is not a function. This is no good. Not a function. It does not pass the vertical line test, because if I draw a vertical line, I'm touching the graph in two different spots. And going back again to my silly little analogy, that means I'm buying 4 hamburgers and it costs $16. I buy those same 4 hamburgers and now all of a sudden it costs $26. How is that possible? That doesn't make any sense. Two different Y's, two different outputs for the same input. Okay. So that's the vertical line test. Last thing I want to cover real quick in this video is the mapping and how we determine whether a relation is a function. And a relation is just a vocabulary term that we use to state that we have some ordered pairs. So let's say mapping functions with our ovals and our ordered pairs with our relations. Let's say that we are putting our domain and range values in these two ovals here, and let's say I have 1, 2, 3, 4. That would be my domain. Domain is just simply a fancy way of saying what are my inputs, what are my x values. And let's say we have outputs of 2, 3, 4, 5. This would be my range. So these would be like my x values, the x's. These would be like my y values. Okay, and if I want to map it, what I'm basically saying is, okay, I'm mapping 1 to 2, and I'm mapping 2 to 3, and I'm mapping 3 to 4, and I'm mapping 4 to 5. I buy one thing, it costs $2. I buy 2 things, it costs $3. I buy 3 things, it costs $4. I buy 4 things, it costs $5. Okay, that's a function. Every x is going only to one y. Okay, what about if I have something like this? Is this a function? Let's say I have the same numbers, 1, 2, 3, 4, 10, 20, 30, 40, and let's say I have 1 that's going to 10, 2 is going to 40, 3 is going to 10, and 4 is going to 20. Is that a function? Okay, and the answer is still yes. Okay, I can have two different inputs going to the same output. I can put chicken breast and chicken fingers and still get out barbecue chicken. That's fine. Okay, what I cannot have is I cannot have the following. Let's say that I have something like, let's use those same numbers, 1, 2, 3, 4, let's go 5, 10, 15, 20. What I cannot have is 1 going to 5 and 1 going to 15, 2 going to 10, 4 going to 20, and 3 going to 10. That is no good. That is not a function because 1, the input is going to 2 different outputs. I buy 1 hamburger, it costs $5. Buy 1 hamburger, it costs $15. Okay, doesn't make any sense. All right. So the last thing we need to cover in this video are the relations with the ordered pairs. Let's say I have something like this: 2, -4, 0, -4, -2, 3, and 1, 4. Now you could redraw these and put it in and map it out with the ovals, and that's fine, but you should be able to tell just by looking at the ordered pairs whether or not it's a function. Now one thing I will caution you, one mistake that I see is that students will simply look at the x values, which is good, and they'll simply look to see, do my x values repeat? Okay, and I'm a little cautious to say look to see if the x values repeat, because you could have x's that repeat. If I have 2, -4, and well, let's look at this first one first. So I have 2, -4, 0, -4, -2, 3, and 1, 4. Okay, and I simply look to see, do I have 1x going to 2 different places? Do I have multiple, do my x's repeat? So in this case, if your x's don't repeat, then yes, absolutely, it is a function. Okay, so if the x's do not, if I do not see, there's no other 2, there's no other 0, there's no other -2, there's no other 1, yes, that's a function, okay, because every x has 1 and only one y, okay, but just because the x's repeat doesn't mean that it's not a function. If I look at something like this, 2, -4, 2, 3, 2, 5, then yes, that is not a function because 2 is going to -4 and 2 is also going to 5, so that doesn't work. But if I had this, 1, 2, 2, 3, 1, 2, and 4, -5. A lot of students will look at this and say, whoops, the x's repeat. No, that's not a function, but actually it is, because 1, 2, 1, 2 are the exact same point. So those 2 points on the coordinate plane would be sitting right on top of each other. So yes, in that case, yes, that is a function. Okay. If you're asked what the domain and the range are, if we were looking at some ordered pairs right here, let's go back to this one. If we were asked what is the range of these ordered pairs, the range would just be the y values and the domain would just be the x values. All right, so in this case, if I were asked for the domain and range of that relation, I would just come down here and say my domain are just all the x values, 2, comma 0, comma -2, and comma 1. That would be my domain. The range for that one would just be all of my y values. So that would be -4, -4, 3, and 4. So I basically only have 3 different range values here. Okay, your domain are your x values, or these values on the left in the ovals. Your range are your y values, or the values on the right in the ovals. Okay. Last thing I want to show you guys. This is a really cool cup. I just want to get you guys your opinion on this. This is just it's just a neat little cup that I found on my table. I just wanted to think, what you guys thought about this. Just nice little clear plastic cup. It holds all my pens. It's got a little symbol right there. It's got some words on the side of it. Just kind of want to get a feel for what you guys thought about my cool little glass. Alright, that's it for this video, guys, and we will see you on the next one.